A lot of time has been spent on the antimatter question, more particularly the antimatter question. It's a tough one because it requires looking all the way back to the beginning of algorithm universe theory to see if antimatter is really antimatter or just an anti-charged CT4 state. And it turns out it's most likely just a charge issue. This renders it a lot less interesting, but it also gives us an opportunity to apply the whole litany of algorithm universe theory concepts to a single phenomena that's seen in this case at the photon electron interface. It's worth noting that it is also applicable in the molecular space and at least as important to us in the molecular space. So looking at it in this one more, or perhaps I should say less dimensional aspect, 3 dimensions instead of the 4 of CT5 molecular states, we actually are just getting a brief glimpse of the complexity of the system. The best solution tracks the model of algorithm universe theory all the way to the CT4, CT5 states, and then rips lines off, and these lines are CT1, 2, and 3 states as the universe has a net expansion, and of course they're not only being ripped off, they're also being attached since you have both compression and decompression, particularly at the molecular stage where the net between how many are being torn off and how many are added is so balanced that things appear to be stable at the molecular state, even though the movement that we observe shows us clearly that they are not at all stable. While the scales can be written fairly easily, they are conceptually complicated and rendered more complicated by moving not only in 2 directions, but also in multiple dimensions. It is like a 3-dimensional chess, but with between 10 to the 16th and 10 to the 32nd pieces, and even extra dimensions winking in and out depending on where you look. The number of possible lines at play for any quantum instant is between 1.67 times 10 to the 22nd and 5.7 times 10 to the 60th, with each of those lines capable of moving in 2 directions. And if spatial changes are taken into account, there's another factor of 256, which, while relatively small by comparison, is nevertheless significant. Moreover, that 1.67 times 10 to the 22nd is the effect on a single proton-electron pair, and it can also affect that pair in multiple places conceivably, and the higher numbers in the 10 to the 22nd to 10 to the 60th range affect any multinuclear or molecular state. While that in itself would be extremely complicated, once time is introduced into this, we add an additional complexity, and we do need time in order to see the effects of electromagnetism, if not the state of electromagnetism in its quantum form. But once we introduce time, we get a minimum rate change at 10 to the 39th of these 10 to the 22nd to 10 to the 60th transitions every second, and perhaps as much as 100,000 times that rate, which is covered extensively in books 1 and 2 in terms of calculating why those rates apply. These rates of change, from our perspective, turn the chessboard of 4 dimensions into a blur, and our senses are designed in order to average the blur to see things in a scale which we can comprehend, and much of the confusion in pre-algorithm universe physics comes from this averaging. While not all of the formula are worked out in algorithm universe theory, given the strength of support for the theory, the geometry of dimension preserved in our formulas for dimension, for example, the f pi x mathematics or part of pi, the more important part, given the fact that non-algorithm universe physics indirectly recognizes that these other dimensional states maintain their dimensional separation. All CT states maintain their dimensional status under algorithm universe theory, and while this is not held to be the case in the standard model, which views space as three-dimensional by way of example and includes time as a dimensional aspect of the universe, even the standard model indirectly recognizes what algorithm universe theory recognizes specifically, which is that dimensional states maintain their dimensional framework and only appear to have more dimensions because of the way that they're folded together to get the higher dimensions. The observed knotted and unknotting nature of the universe, the gravitational and force-based origins and folding and unfolding of these different compression states, all of these things make the idea of the algorithm universe theory underlying symmetry more likely than not. The biggest confuser, which is eliminated very easily by examination of existing data, and especially in light of algorithm universe theory folding and unfolding and the quantum nature of individual moments, is time. While time is critically important to things like force and electromagnetism, in this case, time is an effect and not a dimension at all, and that is shown in algorithm universe theory and explained in quite a bit of detail in Book 3. Although the books discussing the standard model, Books 7 and 8, also cover this fairly extensively. But all of these factors and the failure to recognize these factors in pre-algorithm universe theory leads to a massive misdirection. And once time is eliminated and dimension is properly defined, then all of the missing features of pre-algorithm universe theory physics are eliminated, even though in some cases, like electromagnetism, the process, well, I shouldn't say electromagnetism, I should say matter and antimatter are eliminated, even though the precision with which the alternative is defined is somewhat uncertain, given the fact that there are two alternatives, one being that antimatter is just a aberrational effect, which seems to be the more accurate one, but the related concept that, like an expanding and contracting universe, we can have a matter and antimatter universe, which is a concept that can't be ruled out completely by the current developmental state of algorithm universe theory. Changes in perspective are where algorithm universe theory differs from the prior pre-AUT physics. Instead of taking space-time and saying it is, algorithm universe theory looks at space-time and asks, what are we looking at? And that very important change in perspective is the reason why it is so instructive.